class. We are in 17.3 now. And 17.3 is triangle similarity with AA similarity, side, side, side similarity, and side angle side similarity. What AA similarity stands for is angle angle similarity. So we have angle angle similarity first that I'm going to talk about. If two corresponding angles are congruent, then the triangles are similar. Now, really quickly, just to get everybody's minds on the same page here, triangle similarity is referring to the fact that if I have two triangles and I want to prove they're similar, and yes, there's that word again, that prove word. Okay, we're going to do proofs showing triangles are similar. So these are 3 ways to prove triangles are similar. Now, in order to prove triangles are similar, remember that 2 things have to happen. First of all the angles have to have congruent corresponding angles in similar triangles. So that's number 1. The other thing is all of these sides have to grow by the same ratio, the same factor. So all of the sides, if I take corresponding side divided by corresponding side in all 3 cases, you're going to get the same exact ratio. Now, just like with congruent triangles, we don't want to just prove all this, every single time. It's a lot to prove. So we have these shortcut methods again. Shortcut methods are awesome because then we don't have to prove so much. We only have to prove a little bit of it. And these shortcut methods are proven, and they have theorems that back them up. And we're going to go through those shortcut methods in order to prove triangles are similar right now. So we are going to start with angle-angle similarity. What this says is that if I have 2 triangles and I have 2 of the 3 angles that are congruent to each other, so I have 2 sets of congruent angles, then the triangles can be nothing other than similar. They have to be similar. Now, if I have this angle and this angle congruent, what has to happen with the 3rd angle? It has to be congruent too, right? If these 2 are the same, if they're like 50 and 60, then these are also 50 and 60, then they definitely add to 110. So this must be 70, has to be 70. This also has to be 70 degrees. It just has to be. So really it's angle similarity, but mathematicians like to be as simple as possible, so they only want to list 2 of the 3 angles because it's obvious that the 3rd one has to be the same measure between the 2 triangles also. So what you're going to see here is the proof, and it says, I don't like the pink on this one. If 2 corresponding angles are congruent, then the triangles are similar. Okay, so that has to be true every single time. 2 corresponding angles, which kind of upsets me, but this keeps moving down. 2 corresponding angles and only 2. So for example, if you are asked to determine if the examples below are similar by angle similarity, then what we would do is look at the 2 triangles and determine if there are 2 congruent angles. That's all we need to know. Are there 2 congruent angles? All right, now on first glance, I see one, 75 and 75, but I don't see another one, 74 and 31 are not congruent. However, it's possible that if this one's 75, this one's 75, this one's 74, this one could be 74 over here. We don't know. This one could be 31 over here. We don't know. So what we need to do is we need to find the 3rd angle using our rule that the triangle's sum of their angles is 180 degrees. So we're going to take 74 plus 75, 74 plus 75, helps if I turn that calculator on, is 149, and 180 minus 149 is 31. So indeed it is 31 degrees, isn't it? So now I have 2 congruent angles. I have 31 and 75. So by angle similarity, they are are similar. So yes, by angle, angle, similarity. Now it also wanted us to give a similarity statement, right? So that means that we set up our first triangle. So triangle, how about we go greatest to smallest? So 75 first, 74 second, and 31 third, right? So triangle ABC. Then we do our little similarity symbol. And then triangle, we have to do the same. This one has to be 74 here. So D is the greatest. It is congruent to angle A, 75. And then the 74-degree angle is E, and then the 31-degree angle is F. That's our similarity statement. And yes, they were similar by angle, angle, similarity. All right, let's see the next one here. We have two. Now, all I know on these two triangles is two lines crossed to make the triangles, to form the triangles, and those are congruent angles. So they have a single arc each. But what do we know? We also know vertical angles are congruent. We learned that a long time ago. So with the vertical angles being marked, we indeed do have two congruent angles. So by angle, angle, similarity, these triangles are indeed similar. All right, so we state our statement. Now I'm going to go none, 1, 2. So none is W, 1 is V, 2 is X, is going to be similar to none is Z, 1 is Y, 2 is X. All right, everyone understand that? So those are again proofs. You guys are very familiar with proofs, aren't you? Unfortunately. And with those proofs, we can state that the two triangles sets in that section in those examples are indeed similar because we have similar triangles due to the AA similarity theorem. All right, so the next one that we're going to use is side, side, side similarity. Now, side, side, side similarity states that if you have two triangles and the sides aren't congruent, but this side over this side, their ratio is equal to this side over this side is equal to the ratio of this side to this side, then we definitely have two similar triangles. All right, so that's like, here we'll set up our A, B, C, D, E, F, like we did before. So side AB over DE, their ratio is equal to BC over EF's ratio is equal to DF over AC's ratio. Okay, so if that's the case, and we know that to be true, and we tested all three of the ratios and found them to be equal, then we know for sure that the triangles indeed are similar. Okay, so as you read this, I'm hoping this just sticks, but if all corresponding sides are proportional, then the triangles are similar. Fortunately, it keeps moving down. Here, let me try up there. Oh. Keep missing it. Aha! If all corresponding sides are proportional, then the side triangles are indeed similar. All right, so let's look at the example. So again, we're asked to determine if the examples below are similar by side, side, side. If yes, write a similarity statement. We have two scenarios. We're going to test both scenarios by the ratios of their sides. So these we don't know the congruent angles, and I mentioned that in our video before. If we don't know which sides are corresponding, then we can go small to small. So I'm just going to circle the small one so that I can always know 3 over 6. So we're going to start with this triangle and then end with the second triangle. So 3 over 6 is equal to, and then we're going to find the medium size. So 4 is medium and 8 is medium. So is that equal to 4 over 8, and then the large sides, 5 over 10. All right, that's how I figure out which sides should be corresponding and which sides should have a ratio that is congruent to the other ratios. So these all, if they're the same. Now, I use my calculator a lot. This one I don't really need to, but for some of you, you might need to. You can take 3 divide 6, and then 4 divide 8, and then 5 divide 10, and hit equal on all of those. And in all three cases, you get the same thing, 0.5, and that means they're equal. Every single one of them. If one of them had been 0.4, then they wouldn't be similar. You have to have the same exact ratio every time, and in this case I do. Every single one of those is 1/2 or 0.5. So it does show that they're similar by side, side similarity. So what we would do then is figure out our similarity statement. So what I do with that, because I just mark one side. Q is between 3 and 5, so small and large. So small and large, between small and large is T. Between small and medium is 2, so 6 is small, 8 is medium. And then the third side is medium to large side, and that's our medium to large side. Okay, so sometimes I'll mark them up just so that I can write my similarity statement. So I'm going to go 1, 2, 3, so QPR is similar to TSU, 1, 2, 3. All right, and then we have enough time to do the last one. All right, again, I don't know which angles should correspond to which angles, it doesn't say. So I'm going to start with the smallest. I'm going to circle the smallest so I know that's the smallest. And we're going to check 30 over 24, and we'll do 1 and then 2, left to right. And then medium is 32, medium here is 25, and then the longest side is 35 and 28. So we're going to test all three of those. And in your calculator, you'll take 30, divide 24, hit enter. 32, divide 25, hit enter. And 35, divide 28, and hit enter. Now I got 1. This one is 1.25. This one is 1.28. And this one is 1.25. So what that tells me here, unfortunately, is that this 1.28 makes those two triangles not similar. So nope, they're not similar. And that's because I don't have the same ratio for every one of them. All right, now I do have a couple minutes, but I think this last one is going to take a little longer than that. It's a little more involved. So I'm going to stop the video, and then you'll watch 2 videos again for this section, which is fine. We'll do the last one, and I'll do a couple examples with the last one. All right, on to 7.3, part 2.